This is fundamental problem 1514. In this problem, we have a 15 megagram tank car and a 25 megagram freight car traveling towards each other with the velocity shown. This is car A, this is car B. If the coefficient of restitution between the bumpers is 0.6, determine the velocity of each car just after the collision. So we are given in this problem car A's mass, car B's mass. Car A is going in one direction with a velocity of 5, car B is going in the opposite direction with a velocity of 7, and we are given the coefficient of restitution, and we want to find the final velocity for each car. First, we're going to use the coefficient of restitution that they give us. This is equation 1511, and I can use the coefficient of restitution to come up with a relationship between the final velocities of the two cars. So if I say to the right is positive, then the initial velocity of car A is positive 5. The initial velocity of car B is negative 7, so I can put that into the denominator. And because they tell me the coefficient of restitution is 0.6, that gives me this equation here. I can rearrange this equation by saying 15 plus 7 is equal to 12, multiplying both sides by 12, then I get VB2 minus VA2 is equal to 7.2, and we're going to call that equation 1. For equation 2, we're going to look at the conservation of momentum, and they give me this equation in section 15.4, but in order to use this equation, which comes from equation 15.6, I need to check to make sure that the impulse in the x direction is equal to 0. So if I have car A and car B, and I look at the forces acting on the system, I have a normal force acting upwards on A and B, a force of gravity acting downwards on A and B, but those forces are in the vertical direction, and we're only interested in looking in the horizontal direction. I have the force that A exerts on B and the force that B exerts on A, but these forces are equal in magnitude and opposite in direction, so if I add up the impulse of this force and this force, that's equal to 0. So I can use this equation for the conservation of momentum, and remembering that to the right is positive, I have the mass of car A times its initial velocity. The mass of car B times its initial velocity, which is negative, is equal to the mass times the final velocity of car A plus the mass times the final velocity of car B. So that gives me what I have here. The masses were in megagrams, but since I have megagrams in each term, those are going to cancel out. So now I can take the equation that I have here. I divide both sides by 15 to get this. Well, first I get this. Then I divide both sides by 15 to get what I have here. And that gives me equation 2. Now I have equation 1 and equation 2. Those equations have the same two unknowns. If I add equation 1 and equation 2 together, as I've done here, I can solve for VB2, and I get 0.2. Because this is positive, that means after the collision, car B is going to the right. Then using equation 1, I can solve for the final velocity of car A, which is negative, so that means after the collision, car A is going to the left. And we found the final velocities, and so that's it for fundamental problem 14.